In this round of Let's Make Something Happen from Nothing, when we build it with programming, we are going to work on making a project, or taking the project that we have and extending it. Now I've turned off the enemies so they're not visually cluttering what's going on, and you'll notice here that we have walls that are stopping the progress of the player, which could also stop the enemy, and we can even go from one room to another room, or we can set it up so that we are looping between the areas in a room. So we're going to look at how we can set this up with walls that our player can be stopped by, or we can leave gaps so that the player can move through and enter into a different space. So seeing where we left off last time, where we had the unicorns, I can shoot, gotta hit them, or I can shoot at them and make them go away so that we have enemies. Now if I go to a wall, it just does the same wrapping that we saw before. So what we want to do is to introduce a new class of object that we can work with, and that would be, I'm going to call it a block. But before I do that, I'm going to take the enemies and we're going to ditch the enemies visually so that we don't see them anymore, just to keep things a little bit cleaner while we are working on this. So as we put in the walls, it'll be easier if we don't have the enemies chasing us down. It is going to be useful to see this active area for the enemy, because we will need that, which is going to, or for the player, which represents our height and width, and we will be using that as we try and figure out how to set things up in our project so that we can work with these blocks as we're adding them. So the first step is to add a new tab. I'm just going to call this block. Now we'll start out like the example I showed you where we can see the blocks, and then we are going to stop displaying the blocks, but we'll still have the blocks integrated into our scene so that we are able to then use them as a collision object, not a display object. And then we can just load a simple graphic in the background, which might be why you happen to see Photoshop sitting there in my background waiting for something to happen, and we will probably take a look at that in the next part of this series. But with this, we just need simple X, Y, width, and height. This is going to be a generic display object. Well, in the beginning it will display. After that, we won't even call display anymore. We will just use the X, Y, width and height values of this object. Now, as we set these up, what we want to do when we create this object is we need to pass into it a starting X position, starting Y position, a starting width, and a starting height value. And then if you've been watching enough of the other projects, you'll see that we probably set it up where we do net X is equal to Y, S is equal to SX, Y is equal to SY, W is going to be equal to SW, and H is going to be equal to SH. So I just use the S in there as mental understanding that that is my starting value. These walls, currently, they don't have any moving characteristics, so I don't need to have an update method. In the beginning, when we display them on screen, we will want a display method, and I will just choose a generic color to fill them, a middle gray, and then we'll just draw it at X, Y, width, and height. So it's a really basic class that we've integrated into our project. Now it's not doing anything yet until we draw the objects on screen. So if I want to just create 4 walls around my room to prevent the player from leaving And then internal walls, all I have to do is create a set of blocks. Same way we have multiple images, multiple projectiles, and then those blocks, we are going to check a collision versus the player, but this time instead of just allowing the collision to happen, we will need to modify, so when the player collides with the block, we will have to make sure that the player is not into the block so they don't disappear into a wall. So up at the top, we'll just add in a new value. So we'll create an array of blocks that we are going to use to be, well, not blocks. Block is the class, it's an array, blocks. Now we just need to populate it with the blocks that we are going to draw on screen. So in the sample that I showed before, we can see where I have 2 blocks making up each wall so that you can pass through, and then I have 2 internal blocks as part of it. Now, you don't necessarily have to be perfectly precise with the location of these so that they're not overlapping. All that really matters is that your gap has to be big enough for your object to pass through if you want it to be able to pass through, otherwise it will be stopped while it's trying to go through. And then internal ones, we do have to be more precise as we care about it. So to recreate that visual that we saw there, what we need to do is say blocks is going to be equal to a new block, and this time it is going to have 10. There's 2 on each wall and 2 in the middle, so 4 walls times 2, that's 8, plus 2 more for the internal. That gives me my 10 objects in my blocks array. Now I have a left wall, and this will be, now you'll notice we're not setting this up using a for loop and just cycling through because we're not making a whole set of generic objects. Instead, we're constructing each object to specific parameters. So with that, we just go and say new block, and now we need to specify the 4 values that we are putting into this. So my first block will just be at the top, and with this I'm going to make my blocks 32 pixels tall, and I'll make this block 300 across. So if we just set that up right now and then want to display this on screen so that we can see it. So with that first block there, what I want to do is after we update the player, then we're going to check to see if the player has collided with any of the blocks, and if so, we need to modify the player's position a little bit. And then after that, we can tell the block to display, and then finally we can tell the player to display. So right now I'm just going to display this first one that we have made so we can see what we've done. And now when I test this, we see it created this block over here. So we've proven that it's working. To show all the blocks, we will loop through all of the blocks in the blocks array once we have them created. So to create more blocks, so now we can put the rest of the left wall here. And then this block is going to it'll have an X again of 0. And remembering that the player is 64 tall, if I want the player to be able to go through this opening, I need to create an opening that is at least exactly the same size, if not bigger. It depends on how much slop I want to build into it. So now it is 364 pixels is where we start it on the Y value. It'll be 32 pixels wide once more. And now if we do the math of 364 and our whole thing is only 600 tall, then this makes 236 to be the final value that we need. Now if I want to do my right wall next, and we'll just do a little copy pasting here to expedite the process. But this time, instead of drawing it at 0, we'll draw it all the way over at the edge. So it's 800 wide minus 32 gives me 768. Y will be at 0, then 32 and 300. And then once again, instead of 0, it's 768. So it's useful when we're doing this that if we can find repeating values that we work with, that we take advantage of that. So now, but this won't be 0, 1, this would be 2 and 3. Got to remember that, which I almost forgot that until I pasted in the next one. This would be 4 and 5. 0, 1, 2, 3, 4, 5. So on the 6, 7, and 8, 9 would be our 10 values we're working with. So now for the top. So on the top, I'm going to start at over 32 pixels because we already have the left wall here start going over 32. So we start at 32, and then the Y will be 0. And now if I go over a number that I found that worked okay was 352. Now if we're adding in 64 onto that, then we can say it puts it a little over. So we're trying to find that kind of happy medium of approximate middle of where we want to draw this on the screen. And the height for this will be 32, so the height for the other half will be 32. And then this next one, instead of starting at 352, then what we're going to do is add in our, so with this 352 is going to be 352 plus the 32, then that gives us plus 64, which is the width we're working with, so we end up at 448 for our value. Oh, wait, 32, 0, oh yeah. And then that's going to be 0 because, again, the Y value is 0. We're doing the top. And then our value here works out to be 320 to fit it on screen, height of 32. Now, if any of your values don't mess up or don't work out and you're like, wait, this isn't working quite the way I want. Now, if we just do our int I is equal to 0, I is less than blocks. Well, in this case, I have 6 of my blocks done, so I'll change that to blocks.length in a moment. So I don't have the other 4 done, so we'll leave that out. So instead of displaying the individual one, make sure we need to get rid of that. I'll delete that in a moment. But now if we run this, we should see 1, so we can see how we're getting those blocks showing up on screen. So now that we know that's working for the top, the bottom is going to be virtually the same. But now as we work our way to the bottom, so the X values will be the same. Now the Y values will need to change on it. So instead of being at Y of 0, it's 600 minus 32, which is 568. And then the rest of the values stay the same. Now 2 interior walls. As I go to put those in, and actually I'm going to grab a set of verticals because that's more appropriate to copy paste. So this is not 4, 5, that would be 6, 7, 8, and finally 9. So there's my 10 blocks I'm working with. And now the first block, I'm going to put that, give it an x of 200, a y of 100, and then we'll make it 400 tall. I'll repeat the same thing here, 100, 400, and this time I think 568 is going to give me what I want. Now if I go into the displaying of my blocks here, we'll get rid of that 6. Now this is important to remember. Set it to blocks.length. This is important because now if I add additional blocks or walls in, then I will be able to work with them. And if we start adding in multiple rooms, we can add in additional blocks. We could have a separate blocks array for each room. So there's a number of different ways that we can go about solving this problem. We may want all the exterior walls to be the same and just interior walls to vary between rooms. So then we could set up different arrays of walls that we work and check with as we go through different rooms. So we'll be looking at a couple of different strategies as how to do that when we extend this beyond a single room. But right now we're going to start out with our base room here. And now if I run it, let's see what happens. Now I get the walls showing up. Now you can see the player can run right through. So that's not working out quite right in that we're not stopping it at the walls, but that's because we haven't added that into our code yet. So that's what we need to factor into the code next. So to work on our block collision, it's going to be very similar to the rectangle intersect, but we're not returning any values. We're just going to be modifying the player's position so it's no longer in an object. And we will need to have a similar code for the enemies, so then when the enemies are intersecting the walls, then we work with that the same way that we have player enemy and projectile enemy collisions. So paste that in, get a little red underlining because it's giving me the duplicate method name. So we'll change this, and this will be our player block All right, third time's the charm. Player block collision, and then we pass in player. Wow, the fingers are not agreeing right now. Player and block, but it's not going to return a value. It's just going to be void. Therefore, now we can see how we have these happening here. We're not returning. We'll need something there. So let's put some closing comments in here. And player block. And now this is going to be and successful overlap, because this collision is, we're dealing with overlaps here. So as we go through this, we're going to have to do things a little bit different. So the main meat of our code is going to be in after there has been a collision, then we adjust for overlap. So it's all going to go in here. So all of our code that we'll be putting in pretty much is going to go in here, which is where we know that something has happened. So I'm just going to give myself a space in which to put it. And it's really important to have these closing comments in here because we're going to have enough curly braces running around that it'll be really easy to lose track of them. Now we do need to make a small adjustment here. So the adjustment that we are going to do is we don't want to apply this absolute value method to our distance x and y because we need to know, is it a positive or a negative value, so that we can work with it when we're colliding. Because instead of just looking for collision, we're looking for the overlap, and we need to know which side of the player has overlapped a block. And if we remove any negative value from that distance apart, because this means now if the player's x is greater than the block's x, that means it's to the right, so they'll collide on their left side. But if the player's x is less than the block's x, so then when we subtract that, we get a negative value. That means the player is to the left of the block, and they collided on their right side. So I know that gets a little bit confusing, some mental gymnastics in there, but it's going to be important for us to work with that. Then, instead of applying the absolute value here, now when we're checking to see that distance x and y, this is where we will need to put that in, and we'll repeat that same process here, because we need to be able to know, when we subtract our x positions, we need to know if it's a positive or negative value, because that determines which side is overlapping. So that's the short explanation there. So once we know an overlap has occurred, at that point, we'll set a value of overlap x equal to the combined half widths minus, and I see. It stayed red long enough, I thought I mistyped something. And then here's where once again we use that absolute value, because there we just want the core value. Well, this isn't equal, that's minus. Minus equal, they're almost in the same place on the keyboard, so that does happen. Overlap y is going to be equal to combined half, there's no g in combined, half height minus the absolute value of our distance y. Now it's yellow telling us we created these values, but we haven't used them. Now what we want to do, once we've figured out that the collision will be on the axis that has the smallest amount of overlap. So now if overlap x is less than, greater than or equal to overlap y, that means we want to correct on the y-axis because that's the smaller of the two values. And then we'll know that will be an else, because that's going to be, so this we'll put in here, correct y overlaps, else correct x. Nope. And if I was being judged on the accuracy of my typing today, I would be failing miserably. So now that we have this in here, we need to then figure out if our distance y is greater than 0. So if our distance y is greater than 0, the player top is inside block. So because it's in that, we need to tell R1, which is the player, to take its y and add to it that overlap y value. Else player bottom is inside. I really wasn't kidding when I said if I was being judged by my typing accuracy today, I would be feeling miserably. So if the top is inside this, we need to push it down. Remembering 0 is at the top, and that means we need to push it down by that overlap to get it back out of that block. If the bottom is in it, we need to make it move up on the screen. Moving up means we subtract from its Y position. So now we're going to repeat the same process here and say if distance x is greater than 0 at this point. So if our distance x is greater than 0, that tells us that our left edge is intersecting, so we need to push the player over to the left. So player left is inside block. So that would be r1.x plus equals overlap x. Wow. Typing is just not agreeing today. Else player right is inside block r1.x minus equals overlap x. So now we've been able to kind of work out this logic for it. It's very much the same as the other collision, but instead of just returning that a collision happened, we're figuring out on which edge that collision did happen and adjusting the position of the player. So let's try and put this into practice. So player block collision, we pass into it the player and the block we're working with. So where I'm displaying the blocks, I can now go player block collisions, pass in the player, and pass in the current block that we are working with. Like this. Oh, blocks. And, oh, did I not? Oh, it's not plural. It's player block collision, not collisions. There we go. There's no red. Let's see if this works. So I'm here, can't go into it, can't go into it, can't go into it. So we are stuck. Now I find an opening. Look at that. So we are able to make it work. So it's pretty slick. So we've been able to add in the walls and get it working. Now, the fun part will be to repeat that process and then do it with the enemies. And have the enemies collide with the block so that they can't pass through walls, and probably adjust it so that after you have shot an enemy, instead of making them show up on the left-hand side of the screen, you make them show up somewhere totally off screen so that we don't worry about seeing them anymore, so they're no longer part of the game. I took a screenshot of the project so I could see where the walls were, and I've used it as a guide in Photoshop to make just a single graphic image representing my walls. Now I can do a quick export as PNG that allows me to save out the file into my folder. So put it in my assets so I can save this out. Going back into processing, we're going to add that file to our project. So going up here, pimage, and I'll just call this map room 1. And then we can load that image. Map room 1 equals load image assets map.png. So now we've loaded that image. Don't even need to call background 200 anymore, but just image. And now with this, it would be map room 1 and displayed at 0, 0. Now if we run this, we'll see there's the wall sitting on top of it. That's good, but even better is going into the blocks and saying, well, the blocks, we don't really need to see you anymore. They're just there for guide purposes. And I can't go into the walls. So I can now have artwork representing where I want my collisions to take place and bring that into my project. Now, if I bring back the enemies, we're going to see that the enemies are not going to be bound by anything because they can walk right through walls. Yeah, so it's like they're ghosts or something, and that's troubling. But I can shoot them, that's nice. But I can't. And we can see they land probably in a spot we don't want. So again, we should position them off screen, make them go away. We can decide, figure out a better UI, get the bullets off there on the bottom, or put them into a more strategic location, maybe position it so their resting spot is on the wall or something, so in a non-active part of the room, or we just get rid of them entirely when they're not being fired so we don't look at them. And in our next installment, we're going to figure out how we can make it that when I go through an exit, instead of continuing into the same room, I go into a new space.